We're going to learn a classic technique for handling a tricky trig integral, where a straight substitution does not immediately work. Let's focus on the cosecant cubed part and build a strategy around it. To keep our work organized, let's give the integral a name. Calling it I helps us manipulate it algebraically without losing track of the goal. Here's the key idea. Cosecant cubed can be seen as cosecant times cosecant squared. That split is useful because cosecant squared is tightly connected to cotangent when we take derivatives. This is a great moment for integration by parts. We choose one factor to be u and the other factor to be dv, so that dv is easy to integrate and du is something we can still manage. We pick cosecant as u, so its derivative brings in cotangent, which will match other pieces we can create. Now we compute what we need for parts. The derivative of cosecant is negative cosecant times cotangent, and the antiderivative of cosecant squared is negative cotangent. These choices keep everything in the same trig family, which is exactly what we want. Apply integration by parts. Integral of u dv equals uv minus the integral of v du. Watch the signs carefully here, because both v and du are negative, and it's easy to drop a minus by accident. We're close, but that cotangent squared is in the way. The fix is an identity. Cotangent squared equals cosecant squared minus 1. That replacement is powerful, because it creates a copy of our original integral I, which we can then solve for. Substitute that back into the equation for I. Now you'll see the payoff. An I shows up on both sides, and that lets us isolate I like a normal algebra problem while keeping the equality valid. Getting I on both sides is the goal, because now we can solve for I directly. So everything boils down to the simpler integral of cosecant x. That one is a standard trick. We multiply by a clever form of 1, so a substitution appears in the numerator. Now the numerator becomes the derivative of cosecant x minus cotangent x. That means the integral turns into 1 over u times du, which is exactly the natural log pattern. Great. Bring that result back into the equation for I, then divide by 2. This final expression is the standard antiderivative for cosecant cubed, and it's a nice mix of an algebraic trig term plus a logarithm term. This is the final antiderivative, a cosecant cotangent term and half a natural log term.